share, listen to Aloore Radio on Facebook. Aloore Radio, the voice of Oyo State. Gẹ́gẹ́ bí ìwòye àwọn òmòye tó ní òye bó ti yẹ kí ìlànà ètò ẹ̀kọ́ tó gbangba sùn lọ́yẹ́ orí gan lóde òní yàtọ̀ fáwọn ẹlẹ́bọ̀wọ̀wọ̀ tó lùgbòrò pa lórílẹ̀‐èdè yìí lọ́wọ́lọ́wọ́ báyìí ẹ̀sìn tó ń síwájú ọ̀hún rèé ilé ìwé Monarch Model College Challenge nìbàdàn àwọn ọ̀jọ̀gbọ́n onímọ̀ nípa ọ̀rọ̀ ìlànà ètò ẹ̀kọ́ nílẹ̀ yìí àti lókè òkun ló kórajọ pọ̀ síbẹ̀ àwòsífìlà làwọn èlò ìkẹ́kọ̀ọ́ ìgbàlódé tó sọnù síbẹ̀ àyíká ilé ìwé ọ̀hún rẹwà púpọ̀ ẹ̀rọ CCTV kámẹ́rà ń bẹ ní yàrá ìkàwé pẹ̀lú akẹ́kọ̀ọ́ péréte ní kíláàsì kọ̀ọ̀kan àwọn èlò eré ìdárayá tó kójú owó àwòmọ́ lè lọ lóríṣiríṣi àwọn akọ́ṣẹ́mọṣẹ́ olùkọ́ tó kójú òṣùwọ̀n ní kọ́mọ lọ́dọ̀ wa yàrá ìkọ́ ìmọ̀ ìjìnlẹ̀ sáyẹ́ǹsì tó sọ wọ́n nílẹ̀ yìí gbà ọmọ kan kọ̀ǹpútà kan ní bẹ́ẹ̀ lọ́kọ̀ bẹ́ẹ̀ tí ń káwọn akẹ́kọ̀ọ́ wa láàárọ̀ lọ́sàn-án lójoojúmọ́ pẹ̀lú owó iléèwé tí ò gún pa rárá ayò nílé ìwé yìí jẹ́ fún gbogbo òbí àtàlágbàtọ́ ètò ìgbaniwọlé lọ lọ́wọ́ báyìí o sí ẹ̀ka ti JSS 1-3 àti ti SS 1-2 Monarch Model College wà ní plot 86 and 87 Polaniwa Street Police Post Challenge Ibadan 08169799661 website www.monarchmodelcollege.org Monarch Model College nìbàdàn ibùdó ìmọ̀ fáwọn afàṣẹwà lẹ́yìn ìwà ọ̀la.
Welcome to Monarch Model College, a community of kings and queens. We are located at plot 86 and 87 Polaniwa Street at the back of Equa Church, Challenge area, Ibadan. You are welcome to our teaching on air episode for this week.
So the mathematics class today, as we all know, we've been looking at a very interesting topic, which is sets. And in our last class, we are able to look at the first aspect of sets, which is the operations in sets, which are what the union of a set, intersection of a set, and what complements of a set. Today we'll be looking at the second aspect of it, which is what the Venn diagram. Venn diagram, sets can be represented diagrammatically by a closed figure. This method of set representation was developed by John Venn. A Venn diagram is therefore a pictorial representation of sets. The operation of intersection, union, and complement of sets can easily be demonstrated using the Venn diagram. This leads us to the next slide. Classification involving two sets. We will base our lesson today on two sets only. But you are going to restrict that to one Venn diagram. We'll look first and foremost intersection of sets. Under intersection of sets, it simply means what is belonging to what both set A and what set B. But in Venn diagram, we represent it as this. Now in Venn diagram, we have the rectangular box, which represents what? The universal set. While the two circles you could see inside the Venn diagram are referred to as what? Subsets. We'll be looking at two subsets, which is set A and set B. So we'll look at number one, which is intersection of sets. That means we have here as set A and set B. Intersection of a set using Venn diagram indicates or represents the region that what intersects both what set A and set B. And this is what the shaded portion, as you can see on the board. Where is what set A intersection B. Looking at the board, this shaded area is called what? A intersection B, which simply means the element that belongs to what? A and what? B. This is what intersection means, representing it using what? Venn diagram. Don't forget, I said that the rectangular shape here, or the rectangle here, means what? The universal set. Why this first circular circle here is what? the subset, while the second circle is another subset. Both of them are called what? Set A and what? Set B. And where the intersect is called what? The intersection of both sets. We now move to the next. This is called intersection. Well, we move to the next, which is union. Under union of a set, it simply means we should list out what? All the elements in A and all the elements in B without repeating any one. This is what we treated last week. But today we want to represent that in a Venn diagram. What it simply means is we are going to have our rectangular box which represents what? Our universal set. Then we now put our two what? Subsets inside it. This becomes set A and what? Set B. Looking at the board closely, you will observe that this is set A, this is set B. Universal set simply means, union of a set simply means all the elements in A and all the elements in B without repeating what? Any one. For us to get this clearly now, we are going to shade all the elements in A, which is this region. Also, all the elements in B will also be what? This other region. This is what? A union what? B. It simply means shade all the elements in A and all the elements in B without doing what? Repeating any of the elements. Then, if we are doing this, we are going to shade all the elements in A and all the elements in B. This is referred to as what? A union what? B. We proceed to the number 3, which means complement of a set. The complement of a set simply means that you should list out all the elements that are in what? In the universal set, but not in the set under what? Consideration. Example, if you are looking for what? The complement of set A. That's to say we are going to list all the elements in what? A. We are going to list all the elements in the universal set, but we are not going to list any elements in what? Set A. Then let's represent that in a diagram format. We are going to have it this way. We'll start with the rectangle, which represents what? Our universal set. Next, we are going to draw the subset, which is what? A. We draw our subset inside the universal set. Then A complement now, don't forget we are trying to get what? A complement. It is denoted as what? A what? Prime. I said earlier that it is what? To list out all the elements in the universal set, but not in what? A. Then if we are to shade that now in Venn diagram, it will mean we are going to shade outside the subset of what? A. We are going to shade the outside of the box this way. This is referred to as what? A complement, which simply means you should list all the elements in the universal set, but not in what? The set under what? Consideration. In this case, the set under consideration is called set what? Set A. I hope that is clear. We'll move to number 4, which is called subset. A subset is, let's represent a subset. We have this. We have this as what? Subset. Remember, this is what? Universal set. Then here we are going to have the first circle and we have the smaller one inside it. If we call this A and this is B, if you look closely on the board, you will observe that our set A is the bigger circle, while the smaller one is the set B. And set A and B is inside what? Set A. That means all the elements in B is inside what? Set A. Therefore, we can conclude that what? Set B is a subset of what? Set A. What it means here is that we have it this way, that B is contained in what? A. What it simply means is that B is a subset of what? A, or set B is contained in what? A. What this implies is that all the elements in B are in what? A. Example, let's take a practical example here. If we have an example that set A is equal to, we open our browse, don't forget the representation, how sets are represented. We represent sets in three formats. Number one, we list all the elements in it. Number two, we differentiate it by a comma. And number three, we enclose it by what? A brass. Exactly. These are the three ways of what? Representing a set. Now, we have that set A is equal to, let's state the element as 1 to 10. That will give us 1, 2, 3, 4, 5, 6, 7, 8, 9, and what? 10. We close the brass. We also have set B as what? If we have set B as 2, 4, 6, 8, and 10. You will now notice that all set B are extracted from what? Set A. Therefore, B is a what? Is a subset of what? A, because it is extracted from what? Set A. Now let's move to the next slide. We have what? Set A intersection B complement. Let's do that. Representation of set A intersection set B, all what? Complement. Now look at the board. You will notice that A intersection B means what? The elements that are common to what? A and B. But representing it in a Venn diagram now, we are not looking for what? The complement of that. We are going to shade all the other region apart from what? The region containing what? A intersection what? B. If we represent this in diagram, we are going to have this. This will remain what? Our universal what? Set. Then we now have two sets because we have two subsets here, which is what? Set A and what? Set B. Then if we have this as set A, I also have here as set B. Now to get A intersection B all, okay? A intersection B all prime is going to be what? We are going to shade every other areas apart from what? A intersection B. But this question says we should look for what? Set A intersection what? B prime. So this is different. What we are trying to get here is set A intersection what? B prime. B prime means cut out B completely. Look at this demonstration. If we cut out B completely from here, if we want to cut out B, we are going to remove this point and we are going to clean up this point. What will remain will be what? Only A. That's to say this is the region we are going to shade. We are going to shade only this part. This is now called what? A intersection what? B prime. What it means here is that you will cut off B. Look at this. If you look closely, I've cut off B completely. What remains will give us what? A. Which is what? This is called what? A intersection what? B prime. Do we get that? Then let's move to the next one as the number 6. Then we have here as the set of A union what? B, all what? Complement. We'll start by drawing this. This is what? Our universal set. Therefore, we have our two subsets as set A, and we also have set B. Now, A union B, all complement. A union B means you are going to shade A and shade what? B. But A union B complement means you are going to shade outside what? The box. Because we don't want what? A union what? B. So we are going to shade this region. So we are going to shade this region. We call that what? A union what? B, all what? Complement. I hope that is clear. Then we'll move to the next one, which is set A intersection what? B prime. Okay. Intersection B, all complement. Set A intersection B complement, we are going to have it this way. As this is set A, this is set B. Why the box still remain what? Our universal set. Now, A intersection B all complement. Who can tell us where we can shade here on the board? A intersection B all complement. Where can we shade on the board? Yes, Deborah. Where can we shade?
We shade every other part except from that middle.
We shade every other region here apart from what? A intersection B. So we are going to shade this region. And also we shade outside the box also. So that's how we shade that. Apart from this region here, you will notice that this middle, there is no shading because that is what? A intersection what? B. So the complement means you shade every other region apart from what? That point, which is what? A intersection what? B. Then let's move to the number 8. The number 8 on the board, what we have here is what? A prime intersection what? B. That simply means A prime intersection what? B. Remember, for you to draw this in a Venn diagram, we start from here. The what? The universal set, which is what? Our what? Rectangle. So first and foremost, draw what? Our rectangle, which represents what? Our universal set. The next, we'll draw what? Our two subsets, which is the set A and what? Set B. Then, look at this. We are looking for what? A prime. A prime simply means what? Cut off A completely from it. If we cut off A, you are going to notice we'll cut here off and we'll cut here off. You'll notice this is what? A. Cut A off completely. What will remain? We are going to have this region here, which is now called what? A intersection what? A prime intersection B. I hope that is clear. So if we cut off this region, we have only this as what? The region that satisfies what? These sets. I hope that is clear. Then let's move to the next slide. Now we're about to take practical example here. This is example number 1. So let's bring out the parameters that are given in this question, which is called what? Giving. Let's bring out our giving so that we can represent this in a Venn what? Diagram. Let's read this line by line, okay? In a class of what? 50 students. We'll pick that first and foremost. 50 students means what? universal set. That means, yeah, the first thing given, which is universal set, is equal to what? 50 students. I hope that is clear. Then we move to the next, which is what? 30 speak what? Yoruba. Now, 35 speak what? Yoruba. Now, to represent this, we represent it as number that can speak Yoruba. We represent this as what? N open bracket what? Y is equal to what? We have it as 35 students. Are we following?
Yes, sir.
Hope you are getting the illustration on the board.
Yes, sir.
Now let's move to the next, and we are told from the board, and 30 speak what? Hausa. The number that speak Hausa is what? 30. So we have it as number of what? Hausa is equal to what? 30 students. Let's proceed. The next thing on the board says that if X is the number of students that what? That speak both languages, and every student speak at least one of the two languages. Find I, we are asked to find what? X. Now, our X is what? Number of what? Yoruba intersection what? Hausa is equal to what? How many is that? X. That is the question. Now let's represent this on a Venn diagram. Remember, to do this, we'll start by what? Our rectangular box, which denotes or represents what? The universal set. So we'll start by getting our rectangular box. So our rectangular box, that means what? Our universal set is equal to what? 50 students. Hope this is clear. Now the next thing to do is to represent our next two what? Subsets. And in this question, our two subsets are what? Yoruba and what? Hausa. So we represent our two subsets as what? Yoruba, and we represent the second one as what? Hausa. So we call this Yoruba, and number of Yoruba is what? 35. And we have number of Hausa, which is what? 30. And the intersection, take note of this, that we have Yoruba intersection Hausa. It means what is common between the two subsets, and it will be represented where? Who can tell me? Yes, heritage. Where can we represent that?
At the middle of.
Yes, it's going to be at the middle, which is the intersection of what? The 2 points. That means our intersection here will be what? X. Do you get that? Because what we have here is that the number of what? Yoruba intersection Hausa is what? X students. So we represent that at the middle. But look at this closely. You notice that Yoruba is what? 35. This is not only Yoruba. Only Yoruba now will be what? Only Yoruba will be equals to what? 35 minus what? The intersection, which is what? X. And this area is called what? Only what? Yoruba. We now represent here as what? 35 minus what? X. I hope you are following. Yes. We will proceed from here. You will notice that only Hausa now will be what? Only Hausa will give us what? 30 minus what? X. Don't forget, X is what? The intersection between what? The two what? Subsets. So what we have here will give us what? 30 minus what? X. This is what? Only Yoruba. This is only Yoruba. Why this is what? Only Hausa. Now, to get our answer, we have that our universal set is equal to only Yoruba plus only what? Hausa plus the number of what? Yoruba intersection what? Hausa plus those that is outside the box, and we call that none of what? The two sets, which is what? The number of what? Yoruba union what? Hausa all what? Prime. In this case, the number of Yoruba intersection Hausa is what? 0, because all the students can speak either what? Yoruba or what? Hausa. Do you get that? Then let's proceed towards substitution. Let's substitute. Our universal set on the board is what? What's our universal set? 50. It is what? 50. We have here that 50 is equal to, only Yoruba here will be what? Who can tell me the answer? What is only Yoruba? Who can tell me with that? Yes.
35 minus 6.
Only Yoruba will give us what, Malik?
35 minus 6.
35 minus x. So this will give us 35 minus what? X plus, only Hausa will be what? Yes, Usman? That will be what? 30 minus x plus number of Yoruba intersection Hausa. How can help us with that? Yes, pretty. That will give us what? X. And number of what? Yoruba intersection Hausa all prime will give us what? 0. Do you get that? So this will give us what? 0. The next thing to do here is to what? Collect what? Like terms. If we collect like terms here, what you are going to have here is that we'll notice that we have 50. Let's move all our constants. Let's move our constants to the left hand side and our variable to the right hand side. We have it that 50, let's move 35 here, will give us what? Minus 35. We move 30 the other way, we have it as what? Minus 30 is equal to, we have it as what? Minus x plus what? X. You will notice that minus x we cancel what? Plus x. And we now have here as 50 minus what? 30, minus 35 minus 60 will give us what? Minus 65 is equal to minus x. If we proceed from here, 50 minus 65 will give us what? Minus 15. This will give us minus 15 is equal to what? Minus x. If we look at it now, we divide both sides by what? Minus 1. So divide both sides by minus 1. We now have it as what? Minus 15 all over minus 1 is equal to minus x all over minus 1. Looking at it closely, you will observe that the minus 1 we cancel minus. Minus we cancel minus. We now have it that 15 is equal to x. Therefore, x is equal to what? 15. That is the answer there. We have it as our what? The number of students that can speak. Our x now will be what? Number of students that can speak both Yoruba and what? Hausa. The answer is now what? 15. I hope that is clear.
Yes, sir.
Now we move to II. The number of students that can speak what? Yoruba only. Only Yoruba now. Who can help us with that? Only Yoruba will be what? Is there anyone? Yes, Omotola, help us with that. Only Yoruba will give us what? Only Yoruba will be equals to what? Is equal to 35 minus what? X. And our x is now what? 15. Which will give us what? 35 minus what? 15. And our answer is what? What will be our answer here? 20. That will give us 20 what? Students. Don't forget, you cannot leave this as 15. We put what? The unit. This will be what? 15 what? Students. Do you understand that? Then we move to the III, which is the number of students that can speak Hausa only. Hausa only now will be what? Jamila, do you want to be Hausa only? That will give us 30 minus what? X. So only Hausa now will be equal to what? 30 minus what? X. Which will give us 30 minus, our X in this case is what? 15. 30 minus 15 will give us what? 15 students. I hope that is clear. Now let's answer the last question under this particular question. Now we have it that the number of students that can speak not more than one language. Who can tell us the meaning of that in English format, first and foremost? Not more than one language, what does that mean? Yes, Malik?
The students who speak only one language.
The students who can speak only what? One language. And bringing it to the mathematical aspect of it, it will mean those that can speak only what? Yoruba and only what? Hausa. Do you get that? And the intersection will not be what? Inclusive. So what we are going to have now is, we have here as not more than. This IV, not more than one language. Will be what? This will give us only what? Yoruba plus only what? Hausa. Then only Yoruba, what do we have? Only Yoruba is what? 20 students. So we have it as 20 plus only Hausa is what? 15 students. The total now will give us what? 35 students. So the number of students that can speak not more than one language is going to be what? 35 students. Is that clear? Now let's take the second example, example number 2. Okay, okay, read the question for us for number 2. Read question number 2 for us.
In a recent recruitment exercise into the civil service, 300 applicants were interviewed. 90 were listed as holders of university degree, 120 are holders of national diploma, 65 were listed as both holders of university degrees and higher national diploma. How many applicants were neither holders of university degrees nor holders of national diplomas?
Thank you very much for that reading. Now, let's bring out the parameters out. Let's start with what? Our giving. Our giving. Then, listing. In a recent recruitment what? Exercise into the civil service, 300 applicants were what? Interviewed. Now, what is our universal set in this question together as one? The answer is what? The universal set is equal to what? 300 applicants. Is that clear? Then let's proceed from there. 90 were holders of what? University degree. So how can we represent this? Anyone? How will I represent this? Can anyone tell me that? Yes, Malik.
N into S.
We have N into open bracket what? U. We have it as what? U, which is university what? Degree. Let's use the symbol UD for university degree is equal to what? 90. Do you get that? While we move to the next one, 120 are holders of what? National what? Diploma. Let's represent national diploma as what? N what? D. So we have it as number of what? ND is equal to what? 120. Now, we are told that 65 were what? Listed as holders of national what? Holders of university degree and higher national what? Diploma. Then what it simply means is that the number of UD intersection what? ND is equal to what? 65 applicants. Do you understand that? Then the person also we should look for what? How many applicants were neither what? Holders of the university degree or what? Holders of what? National what? Diploma. What this simply means is what? The number of what? UD union what? ND all what? Prime is equal to what? X. So we say let that be what? X. Now let's represent this in a Venn diagram. We are going to have it this way. We are going to start with our rectangular box. Then we put what? Our universal set up here. Our universal set is equal to what? 300. So we put here 300. Then we are going to have two subsets, which are what? The university degree and the national what? Diploma. So we represent that here as our first subset and the second subset. So we call this as what? UD and we call this as what? ND. Proceeding from here, our number of UD is what? What is our number of university, holders of university degree? That would be what? 90. Why holder of national diploma will be how many? 120. Why the intersection of both of them is what? We have this point as what? 65. Now, the number of university degree, union what? National diploma, all what? Prime means what? Outside what? The box. We put it anywhere, can represent it here, or here, or here, we represent it as what? X. Do you get that? Finally, we need to get only what? UD. Only UD is equal to what? 90 minus what? The intersection, which is what? 65. And the answer will give us what? 90 minus 65. What do we have there? That will give us what? 25. So we have here as what? 25. Why the next one we have it as only ND is equal to what? 120 minus what? 65. This will give us what? 55. Hope you can see that. This is equal to 55. So we now write here as only UD is equal to what? 25. And only what? ND is equal to what? 55. Now, we now get our final representation, which states that our universal set is equal to. Who can give us the representation of this universal set now? What are we going to have? What will this give us now? Anybody? Yes, Deborah, help us with that. Only the universal set now will give us what?
Only university degree.
It will give us only what? UD plus
only ND
plus only ND plus what?
number of U
intersection ND.
UD intersection what? ND. Plus finally,
Plus number of UD union ND all prime.
number of UD union what? ND all what? Prime. I need someone to help us with the substitution. Who can help us with the substitution? To substitute this. What is our universal set here? Our universal set here is what? We have it as 300 is equal to only UD is what? 25. Plus only ND is what? 55. You can see that on the board. Plus number of UD intersection ND will give us what? What do we have there? That is 65. And finally we have the number of UD union what? ND all prime. This will give us what? X. That is the unknown we are looking for. Then from here we collect what? Like terms. So if we do that, we are going to have 300 is equal to 25 plus 55 will give us what? 80. 80 plus 60 plus 65 will give us what? 140 what? 5. So we have here as 145 plus X. If we proceed here, we now collect what? Like terms. If we collect like terms here, we are going to notice it that 300 minus what? 145 is equal to what? X. We've moved our 145 to the other way. Therefore, it will no longer be positive, it will become what? Negative. If we proceed from here, we now have it that 300 minus 145 will do it one side, which is minus 145. The answer here will give us what? We'll borrow 1. The final answer, FB with that will give us what?
155.
That will give us 155. That means 155 is equal to X, therefore X is equal to 155. The unit will be what? Applicant. So that will give us what? 155 applicants. I hope this is clear.
Yes, sir.
Now we'll move to the next question. This is example 3. You read it line by line. Once you come across the first figure, you stop. So we'll pick the parameters there. This is now example 3. Now we'll start with our given, which is the parameters in the question. Let's start.
In a science class of 42 students.
You stop there. In a science class of what? 42 students. That 42 in this question refers to what?
Universal set.
It refers to what?
Universal set.
The universal set. Our universal set is equal to what? 42 students. Proceed with the reading.
Each student offers at least one of mathematics.
This means that each student offers at least one of what? Mathematics or what? Physics. Proceed.
If 22 students offer and 28 students offer mathematics.
No, stop after the first digit. Let's bring that out.
If 22 students
Offer what? Physics. So what are we going to have here as a class? This will be what?
Number of physics.
Number of what?
Physics.
Number of physics will be equal to what?
22 students.
So this will give us the number of physics is equal to what? 22 students. While the next one we have it as number of what? Mathematics students is equal to what? 28 what? Students. So what else? We have to find what? How many students offer both subjects? Now let's do that quickly. Solution. For us to get this, we need to represent this in what? In a Venn diagram. And we'll start by what? The rectangle. So we have our rectangle here. This is our rectangle, which is our universal set now is what? For the universal set, 42 students. Now we have two subsets here, which are what? Physics and what? Mathematics. So we quickly draw our two subsets. Here become what? Physics, and here is what? Mathematics. You will notice the number of students for physics is what? 22. While for math is what? 28. And we are asked to find the intersection. Our intersection is what? X. That's what we are looking for. So our intersection is X. So we are now asked how many students offer both. Now we are told that there is none that do not offer any of these. Therefore, our universal set is equal to what? Only what? Only physics plus only what? Mathematics plus what? The number of what? Physics intersection what? Mathematics plus what? Those that are what? Outside the box, which is number of what? P union what? M all what? Prime. Finally now, we have it this way. As our universal set is what? 42 is equal to, only P is now what? 22 minus X plus, only N is what? 28 minus X plus our intersection X. None of them will give us what? 0. So if we have this, we collect like terms. We are going to have 42 is equal to 22 plus 48 will give us what? 22 plus 28. 50. This will give us what? 50. Minus X we cancel plus X minus X. We move minus X the other way. We have it X is equal to what? 50 minus what? 42. Our X is equal to 50 minus 42. We have it as what? 8 what? Students. In this class, the number of students that offer both physics and mathematics is now what? 8 students. Is that clear? Now, we are going to stop the class here and we'll continue in our next meeting. As usual, your assignment is going to be sent via your WhatsApp what? Page. By this evening, if you log in, you will meet your assignment already sent. Thank you very much. We'll meet next class.
Thanks so much for joining us for this week. Have a pleasant week ahead. See you next time.
Oh yes, your long-awaited citadel of true education for the rare gems. Monarch Model College Challenge Ibadan. Intelligence with good character makes up the real goal of true education. Parent and guidance. Connect your child to the arena of kings and queens, where quality and sound education is undoubtedly available. It's a government-approved school that stands tall among others with the best and globally acceptable standard of teaching. Beautiful and hygienic learning environment. Professional subject teachers. Well-ventilated classrooms with small class size. Ultra-modern science laboratory, standard music lab, standard computer laboratory, maximum security with CCTV surveillance. School buses are also available, all with affordable school fees. Admission is ongoing into GSS 123 and XS 122 classes. Application forms are available at Monarch Model College, plot 8687 Polariwa Street, behind Equa Church, Police Post, Challenge Ibadan. 0069799661. Website www.monarchmodelcollege.org. Monarch Model College, a community of kings and queens.
Share, listen to Aloore Radio on Facebook. Aloore Radio, the voice of Oyo State.